Hello, today we shall discuss about context-free grammar, a language-defining construct for describing context-free languages. As we all know, regular expressions are used for defining regular languages, and finite automata is a mathematical model which accepts all regular languages, and we can accept only regular languages using the finite automata. There are some set of languages for which we cannot define regular expressions of this language cannot be described using regular expressions. So we need a more powerful language defining construct in order to describe such languages. Languages which are not regular are a language is of the form a to the power n plus 1 where n is bigger or equal to 0, or a language is consisting of all strings w which is of the form palindrome. These languages cannot be described using regular expressions. We cannot write the finite automata for accepting such languages. Context-free grammar is used for describing a set of languages called as context-free languages. If a language L is accepted by a finite automata, then L can also be generated using context-free grammar. But the converse is not true, because all the languages which are generated using context-free languages may not be accepted using finite automata. So how do you define a context-free grammar? Context-free grammar definition has four tuples called as D, T, T, is where E is a finite set of variables or non-terminals, T is a finite set of terminals or also called as alphabets, P is a finite set of productions or roles at the top, A giving alpha, where A is a variable and alpha is a string of variable and terminals of 0 or more. S is a start symbol which is a variable and single non-terminal on the left hand side of the production which makes grammar as context-free. So example for context-free grammars, let's consider an example language L is the form a to the power n, b to the power n plus 1 where n is greater than or equal to 0. It's not a regular language, so we can describe the language using context-free grammars, wherein we need one variable in order to describe this, and there is a need of two productions. The second production S given A is B, which will generate all the string consisting of equal number of A's and B's, and as we need one additional B in order to accept the string, the production SB will result in that. And the starting variable is taken as S, as there is only one variable in the definition. Now, what is a derivation? Derivation is a process or procedure to prove that a string can be derived from the given grammar declaration. While for deriving, we repeatedly apply the production rules starting with the start symbol S, and at the end we are supposed to get the string belonging to the language. The derivation can be one step or 0 or more step method. The one step derivation is represented by U giving V, where U is a string of the form X alpha Z and V is X beta Z. X alpha Z will give the string X beta Z if and only if there is a production alpha giving beta in the set of productions. It can be 0 or more step derivation, which can be represented by U in multiple steps, that is star gives V, which is a chain of one derivation of the form U giving U1, where U1 gives U2. In the last step, it is going to generate V. If the star is plus by 0, means U is equal to V. So what is a context-free language? Context-free language consists of all the strings W which can be generated from the starting variable of the grammar in one or more step or 0 or more step. Consider another example. The language consisting of string, all string W, where W is a palindrome over the alphabet A to B. The length of the non-zero length palindrome, the simplest palindrome we can get is A in B. And all the other palindrome of greater than 1 can be generated using the production S giving A is A or S giving B is B. Where the string starts with A, it also should end with A. If it starts with B, it should end with B. So recursively we can apply this definition and we can substitute either A or B. We get all the palindromes which are of odd length. If you want to get even length, we need to have another production is giving epsilon in this definition. We have an example for which we cannot describe the language using context-free grammar, that is A to the power n, B to the power n, C to the power n beta n equal to 0. This is not a context-free language. Past. Past is a pictorial representation of the derivation, pre-representation of the derivation. In the past, we have internal nodes which are represented as variable, and the leaf nodes, it's the final yield string in all the leaf nodes are terminals or epsilon. If it is a sentential form which is not a terminal string, then the leaf node can be a variable also. If a rule A giving A1, A2 up to A1 occurs in the derivation, then here is a parent of the node labeled A1, A2 up to A1. This is an example for the past. Now there are for a particular string we can have any number of derivations, as each sentential form during the derivation process can consist of any number of variables. We can apply the definition of a variable in any form. In order to resolve this ambiguity, we use only two types of derivation called as leftmost derivation and rightmost derivation. In leftmost derivation, at each step of the derivation process, we replace the leftmost variable by one of its production values. In the rightmost derivation, at each step of the derivation process, we replace the rightmost variable by one of its production values. So, the ambiguity of during the derivation call can be solved using one of these methods. This is an example for the derivation. We have a grammar with the production as displayed here. If you want to derive the string AABB, we use either leftmost or rightmost derivation. All the other types of derivations are highlighted. Leftmost derivation, where we start with the starting variable S, substitute the definition A and B, S giving A, B. Finally, at each step of the derivation, we replace the leftmost variable with the production bodies, and finally we get string A, B. And in the rightmost derivation, we start the starting variable A, S, and at each step of the derivation, we replace the rightmost variable in the sentential form in order to get the string A, B. This is all about the context-free grammar and the derivation to prove that a string can be generated from the given grammar. Thank you.